Did you know that engineers solve real world problems from the principles and inductive understanding they have learned? Students will understand the most basic analytical tools for mechanical analysis and also in predicting failures. Mechanics of deformable bodies helps the students to explore, sample problems in detail for them to recognize situations and respond accordingly.
Hi, good day. Today, we are going to solve one of the problems of the mechanics of deformable bodies, specifically the topic about stress. But before that, we are going to define what is stress.
Stress or simple stresses are expressed as the ratio of the applied force divided by the resisting area. It is the expression of force per unit area to structural members that are subjected to external forces and induced forces.
And now, to understand more, we will answer one problem from the topic stress.
A homogeneous bar is supported by a smooth pin at A and a cable that runs from B to C around the smooth peg at D. Find the stress in the cable if its diameter is 0.7 inch and the bar weighs 7,000 pounds.
So for this problem, we have the given weight of the bar equals to 7,000 pounds and diameter of the cable is 0.7 inch. As we all know that the area of circle is equal to pi r squared and we're only given the diameter of the cable. Since radius is half of the diameter, we can replace r by d over 2 and the square of 2 is 4. So for the equation of the area, we have pi over 4 multiplied by 0.7 inch squared.
So here are the steps in solving this problem. First, we have to make a free body diagram or the FBD. Second, we have to make summation of moments. Third, we have to solve for tension. And lastly, we have to solve for the cable stress. Since the problem uses cable, the force involved here is tension force. At point B, the arrow is pointing upward as well as the cable at point C because it pulls the bar that weighs 7,000 pounds. Since the bar weighs 7,000 pounds and its length is 12 meters, its centroid is at half of its length, which is 6 meters from pin A.
After making an FBD, we can now then proceed in making the solution. However, we must not forget that we are asked for the stress and not for the tension.
In finding the tension, we will use summation of moments. We will set summation of moment at A equals to 0 counterclockwise positive. From the FBD, we have T multiplied by its distance from A, which is 6 meters, plus T multiplied by its distance from A, which is 12, and to get its y component of this diagonal, we will multiply it by 3 over 3 square root of 5. Notice that these two are positive because it rotates in a counterclockwise direction with respect to A. Since it is in the clockwise direction, if we rotate it, its sign is negative. However, if we transpose it to the other side, it becomes positive. So by simplifying the equation, we can get the value of T, which is equal to 3,695.05 pounds.
Since we already have the value of T, let us recall the definition or the formula for stress.
Stress is equal to force over area in which in our case, we have force as a tension force. By substitution, stress is equal to 3,695.05 over area. We can now compute for the stress in the cable, which is equal to 9,601 0.39 psi or 9.6 ksi. If you wonder why its unit was psi, it is because the unit for stress is in pounds and the unit for the area is in square inch. Thus, the unit of the answer must be pounds per square inch.
And that's all for that problem. Thank you so much for watching. I hope you have learned something from it. God bless.